Whoops. Okay, we're ready. We're going live. Hello. Settle down. Thank you. I know I have to say this again, but is there attendance list going around? I sound like a parrot at this point. All right, so we started collections, right? Good. See, somebody actually has to remind me where I stopped the last lecture. No, that was the other class. That was the Oracle class. I didn't finish half the lecture, and I went into another one. I know we started this one. All right, but I want to review a little bit because some people may not have been here last time. And can we, I don't know, there's people coming out of that back door over there. There's people coming out of that door over there. If we can get the volume down a little bit. There we go. Perfect. Yeah, tell your neighbor to be quiet. Okay, there we go. All right. We started talking about collections last time. Before I started here, I queried around the class to find out if anyone wanted anything about assignment number 2. And everyone said that they were already done with it. So if you want some help on assignment number 2, actually before, you know what, let me just show you now. Before I get too involved in this, let me show you what I did this weekend. So for those of you who are struggling with the assignments, and I know you're struggling with the assignments because I've had some people tell me, hey, so-and-so posted something on some weird bulletin board out there. They posted the entire assignment looking for a solution. And if you do an internet search on the assignment text descriptions, you're going to find it's used in 2 other, Ohio State, and there's another university that uses it. It comes out of a book, actually. This assignment is out of a book. It's recycled. Or not recycled. It's actually not bad. All of them are actually out of a textbook so that they're solid assignments that are testing solid concepts that, there should hopefully be clear and straightforward. Which means if you do a search on it, you'll find other assignments out there, but you're not going to find the answer to it. Well, I can tell you right now, there is absolutely no solution to any of these assignments out there on the internet because people are very cautious with that. They'll remove it. There's one ITU student who posted something on a bulletin board, actually, and you might find it, actually, if you search on some of the assignment number 2. And then luckily one guy on the board said, hey, this looks like an assignment for a class. Why don't you do it yourself? And I'm like, yeah, because I was getting ready to delete that posting if they had provided a solution. So I'm out there looking. I'm making sure you guys aren't cheating. But, it's just one student who did that. Actually, I didn't say that. There's a couple other places where other students have posted code samples that weren't working, asking for a solution. So here's what I did for you. For those of you who have already done it, good. You learned a lot from it. For those of you who are still struggling with it, I put together over the weekend some pretty extensive how-to videos. So you'll see one for assignment number 2, you'll see one for assignment number 3, you'll see one for assignment number 4. You won't see anything for the ping pong applet, assignment number 5. Because lucky for you, your weekend students, we had our last interactive, I shouldn't say our last, we had our middle interactive session this weekend. And by unanimous vote of the entire class, everyone said number 5 should be extra credit. And being the nice teacher that I am, I said, well, you're probably right, actually. If I can get 4 decent programs out of you, I think number 5 should be extra credit. So if you've done it, it's extra credit. If you haven't done it and you don't want to do it, don't worry about it. Number 5 deals with changing an applet to an application. The conversion of the applet to the application is not bad. Implementing the requested features is worth, the effort that you have to put into it is a lot more than what 5 points is worth. I mean, it's ridiculous. I took a look at it and went, yeah, they're right. It's too hard. Because those guys are already working on number 5, and a lot of them had questions on it. So, long story short, do number 1, 2, 3, 4. Turn those in, you'll get 25 points for your assignment portion of the course. If you do number 5, you'll get 105 points possible, which means you can miss 5 points on the final exam and still get an A in the class. But you're not going to miss 5 points on the final exam. And you're not going to miss any points here because what you're going to do is look at if you're confused, you're going to watch the videos. I give you practically everything except for everything. So I give you 90% of it. So you can pause the video. I'm not going to, and I've already had students request this, and no, I'm not making the source code available. It's too easy if I do that. I might as well just write the program for you. So you have to watch the video, write your source code, pause the video, write it. If you want to copy it off the screen, you can do that. It should be legible enough. But I would hope that you would actually use it as a double check. So you got lost, something's not working, you can kind of compare it against, and this is just one implementation of each one of the programs. And it will hopefully put you in the right direction and provide some help, is what the purpose of it is. This one here doesn't do it all for you. Oops, this one up here, the second one doesn't do the whole thing for you. It just basically shows you how to create the hierarchies and how to use the public and the class methods and the class method. Yeah, methods is what I meant to say. And class variables versus the instance methods and instance variables. It kind of demonstrates. And it's about an hour and a half to hour and 45 minutes long, and I tell you all the concepts that are associated with it. So it's a learning tutorial / example of what you're supposed to do for this assignment. You might also find the fourth one, just in case I forget to mention it. I'm going to go over the third. Actually, I'm not going to go over the entire video. The video is different than what I'm going to show you today, but we're talking about collections and data structures, stacks and queues and stuff. And I put together 4 little examples that are in this video. So you'll see it in the video, but I'm going to go over the examples so I can kind of put all this stuff into perspective for you. So you can see how collections work and how the interfaces are put together. And this fourth one actually gives you a text editor. It's not too hard, actually. It won't give you the style. It won't give you the style. And we haven't even talked about GUI swing stuff yet. That's coming up, actually. But it's not towards the end. So now that we don't have to do number 5, I can kind of space it out a little bit, too. And not have to rush a little bit. Because I'm not going to cover everything there is to know about applets and stuff like that. Why this is optional now. So I was looking at the material going, well, what does that have to do with object-oriented design? It's Java programming. So that's how I kind of decided, well, I can actually take that one out, and we wouldn't be missing anything at all. So yes, this is where you go. And this is where you're looking at is in the assignments link in the weekday schedule. And anyone have any questions about the assignments before I continue? Nope, good. Everything is due the very last day of the course, except for the midterm exam, which is due on April 17th. Is it 17th or 18th? 17th. What day of the week is 17th? Sunday? Sunday the 17th. I guess there's 31 days instead of 30 or something. I don't know. I don't know how that works, but all right. Now let's go revisit. Probably should have just started there to begin with. All right, so last time we met, we were talking about collections, and we were talking about the java.util. In fact, this is what you need, essentially, to use this package, and it has lots of interfaces. We talked about interfaces. We talked about abstract classes. These aren't abstracts. These are interfaces, which means it runs a little bit differently. In fact, what we have are the methods. We have the information for basic functionality. And what we do is we build from this to add on our own. So what you're doing in the assignment number 3 is taking a map, hash map something or other, can't remember what it's called, and modifying it. You're adding methods to it to add an item, to remove an item. So you're getting the functionality. And we talked about these 3 kind of components or interfaces that are part of the collection framework. The concept of the collection, the concept of the map, and the concept of the iterator. And I think I probably started talking about data structures. Do you guys want any more information on the concept of what these data structures are all about? No. See, nobody's going to say anything anyway. All right. So I think we covered a little bit of an overview of that. What I'm going to do today is show you an example of an array list, of a linked list, because it's a lot easier to see the source code. But I kind of want to get through the lecture stuff first so I can reinforce it with those concepts. And then I'm not going to show you very much about a map, although I will show you the hash map implemented, because that's really your assignment. So I don't want to give the whole entire assignment away. And the iterator. We'll implement an iterator, and you'll see what that means in terms of the concept. So in terms of the root interface, we were looking at, and this kind of reads like Greek if you're looking at it, because it's a bunch of stuff on, a method for size, a method for is empty, contains, add, remove, equals, and great. What does it all mean? It's giving you functionality for objects that you create of this particular type, and the collection itself could be ordered, could be unordered, could be a list, could be a linked list. You guys all know what linked lists are, actually, and array lists? You guys know this stuff? This means yes? Okay. I'm surprised because my weekend class, they didn't know any of this stuff. Either that or they just wanted to hear me talk, I don't know. They were going, what? If you're an old C++ programmer, you really love Java right now, actually. Because C++, you had to create your own linked list. You had to create your own iteration and stuff like that. And in C++, if you didn't like arrays, you were stuck, unless you wanted to create a dynamic array using pointers. In Java, we're going to see in a few minutes, we have an array list. It's a growing array. It's an array that doesn't use the same kind of structure as traditional arrays do. So we'll see that. I'll see an example of that in a few minutes. And then we have the iterator. In C++, actually in Java too, when you create an array, everyone's familiar with the for loop. And I actually kind of wondered, why in the world do we have a loop? Why do they make the programmer create a for loop? For I is equal to 1, I is less than the array size, I plus plus, and go through each one of the array index I, go through each one of them. That's iteration, that we're all familiar with. But why bother with that? So if you're using objects in an object-oriented environment, you have a collection. You can create an iterator object. And the iterator object can work directly with the collection. It's connected to the collection. So you can go through and do, is there a next? Is there a next? Is there a previous one? And you can use built-in methods that are part of the object of the iterator that you've created. And I'll show you an example of this as well, to kind of do the same thing that you would normally do with a loop. So you don't have to do a loop. Instead, you use objects in an object-oriented fashion. So the collection interface defines the iterator method, and it returns an object implementing the iterator interface. So if you missed the interface lecture, it's probably not a bad idea to go back and watch that video or look at the slides. Because what we're doing with all of these are implementing interfaces. And we can implement multiple interfaces with one class. As we saw before, we extend another class to inherit it. We implement this interface, comma, that interface, comma, that interface. So we can implement an iterator, and we use that along with our linked list or our array list or anything else that we're creating and using, which makes it very easy compared to C or C++. There's no guarantee concerning the order in which the elements are returned. The structure is managed well, it's actually the JVM that's managing the memory addresses, but it's managed by the object. Just the same way as when we create an object, a person object, we don't know exactly where anything's being stored. We just do a dot notation and we get at it through reference, which is sort of like what we're doing in terms of the collection as well. So 3 defined methods, an iterator interface has next, and remove, so that we can remove items, we can add, we can see if there's a next one, we can go to the next one. So it gives us that functionality. Here's a classic routine of an iterator where we have remove the long string. This is going to be a method to remove a long string. And the iterator IT is going to be a method iterator called on the collection that we're using. And we'll see an example. It might make a little bit more sense. In fact, I think I'm going to skip most of these examples because you can't really see it run or work. But anyway, you're using a while it.hasNext. So while we have a next one, this functionality is given for you already. So you're just calling the iterator method to invoke the iterator so that you can go hasNext. Is it the next one? Next. Previous. Remove. So in here we have IT next, which means take the next one instead of does it have another one? Instead of finding one, we're going to take the next one, check the length, remove it, do all sorts of things with it from an iteration point of view. We also have a list iterator that allows us to modify the list. So the basic iterator allows us just to go through. We remove an item, but go through and iterate through the list. The list iterator interface extends the iterator interface, so it adds a little bit more functionality. It adds methods to manipulate the order of the list items. So we're actually changing the order, and I'll show you an example of that as well. We're changing the order of those objects during the iteration. And why did they make those into one? I don't know. Because I guess they wanted to make it so you had no way. It's kind of like when you play around with arrays, you pass them back and forth to functions. You have that side effect of accidentally changing them. Here, you know, it's kind of like separate them out. One you can change, one you can't change. So it kind of keeps it safer, I believe, in terms of the iteration, because you're allowing modifications to occur versus not. The same kind of functions has next index, remove, add, set, you know, all sorts of different functionality that's associated with it. And potential problems with the list iterator and the list iterator and iterator, they don't provide the snapshot guarantee. So if the contents of the collection is modified when the iterator is in use, so after the iterator started being used, it can affect the various values of the methods, because it only knows what it had when it started the iterator. When the method first invoked, it takes a snapshot of what the environment's all about. If you're manipulating stuff outside of that, which means if you're running a program that's kind of like a state machine or something that's iterating through, and things are changing, this might be not in sync with the things that are changing. So you can't really use it for like a state machine if you're familiar with that concept, or a program like a network. A state machine would be like a network analyzer that constantly loops through, iterates through, and constantly looks at ports for activity, as an example, and saves that information to know that someone's been attacking a port for 5 minutes. But in this particular case, the snapshot's not going to be updated unless you stop the loop and then start the loop all over again as soon as the environment changes. So that's one of the potential problems. The snapshot will return the elements as they are when the iterator object was created, which is unchangeable in the future. So it's really neat, a snapshot. You can simply copy the collection into another and create your own artificial copy or snapshot of the environment. So not really a big issue at all. And I'm not going to go through those examples because I have a better one that I'm going to show you in a few minutes. The concept of the list. So the list is an ordered collection which allows duplicate elements. So if an element indices ranges from 0 to the size of it -1, just like an array, the index value starts with 0. Add several methods for an ordered collection, so we can order it. And then the interface list implemented by two classes, the Arraylist and the linked list. And I'm going to show you an example of those as well. So when I show you the example, you're going to go, what? What do you mean? Go back to the lecture. It's the one on collections number 6, I believe, and read through the stuff you're probably not reading right now, and you'll get the better definition of it if you need it. So the array list is kind of like the array, except it grows. It's not statically fixed. It's a dynamic array. And the linked list has more functionality to it. So in terms of the array list, a resizable array implements the array interface, or the list interface, adding and removing components at the end, getting an element at a specific position. We have all sorts of different methods that we can run in it to give us more functionality than a regular array would. And can be efficiently scanned by using indices without creating an iterator object. So the list, if we actually create a list, we have an iterator in there already. We only need the list for unordered collections, or collections in general, I shouldn't say unordered. Just the collection concept requires the iterator, or comparable, to compare items back and forth. So you can kind of look at the hierarchy and go, well, lists and linked lists are further down the tree. Because they already have comparable, they already have iterator, they already have the collection involved in them. And we're looking at a higher level, more sophisticated, more implemented functionality. This is what you can do, and this is what you're doing actually in the assignment, is you're creating your higher level functionality for a structure that's built upon some of the previous layers in the hierarchy, which makes this object-oriented design and not just programming class, because you're looking at the hierarchy, you're looking at the inheritance of everything. Okay, so the iterator is built right in, can can be used without actually having to create one, and we'll see an example of that. And then the linked list is a doubly linked list if you're familiar with C++, but we don't have to actually create one. It's given to us automatically. We just create a new object of that type. So we get an element at a position I. It's more expensive. So a good basis for lists where most of the actions are not at the end. So we start at the front. We always add to the front of the list for optimization. I think this is going to, I don't know if this is going to print out, but this is linked to the linked list example I'm going to show in a few minutes. The real question is what happens when you download the slide set. It's not going to be on the same server. So we'll see how, I might have to edit that. Then we have sets and sorted sets. So a list is indexed 0, 1, 2, 3, 4, 5. A set doesn't necessarily have an index to it. You can order it and sort this set and create the index on it. But the set interface provides a more specific contract for its methods. Adding no new methods of its own, the set is a collection that contains unique elements instead of the array lists or the linked list where you can have duplicate elements. So if you want a set, you can only get one of each. So the sorted set extends the set to specify additional contract iterators so that you can put it in, return the elements in a specific order, backwards, forwards, alphabetical, or whatever you implement actually. Because what the object is, you take this and you implement your own specific functionality using these as base classes. So you're building your more sophisticated implementation of it. So by default, it will have elements in natural order, which is determined by the implementation of the comparable interface. So just so we had an iterator to go through each item in a list, comparable is used for, are you an instance of this? Or are you equal to this? Are you larger than or less than this? So we compare items with each else, just in terms of comparison. The comparator is like tongue twister. So you can specify a comparator object, and we'll see an example of that, to order the elements instead of the natural order. So if we take a list, implement a comparator on it, then we can order it and sort it, depending upon how we're going to compare the objects. Because, as you know, there's probably different ways of comparing it depending upon what you've got, essentially. And so there are two implementations of the set in the collections work. We have a hash set, which is a set of implemented using a hash table, and tree sets, so it's a sorted tree implemented in a balanced tree structure versus a hash table. So an example of it. An example of using a hash set is on this next slide. Nope, took it out. Okay. I took out the example because I didn't want to link to them. So I'm going to show you anyway outside of it, so we'll see that in a few minutes. And now this is where everyone wakes up. Oh, map, sorted map. Oh, that's like the assignment number 3. So the map interface does not extend collection. So the interface becomes a map, contains a key value. So a mapping dictionary. Think of it that way, key value. Not only keys. So duplicate keys are not allowed in a map. So it's implemented using a hash map and a tree map. Our assignment is going to use a hash map, I believe, if I remember that correctly. So there are methods to view the map using the collection. For example, here we have key set for the collection. So the collection returns, you ask for the key, it'll give you the value. You ask for the value, it'll give you the key. You can set the value by calling the key, just like sort of like a dictionary. You know, define the definition of this key. Here's the value for it. So you have that association. So you cannot add elements to these collections. You create them. So removing an element from one of these collections removes the corresponding key value from the map because they're in sets. You can't just remove the values. You have to remove everything. If you iterate through the key value sets, you might return values from their respective sets in any order. There's no order to it, so you don't have a natural. You just have whatever way they were put in. It's not necessarily the way they're coming out either. In fact, we'll see an example of that where things are just put in, and depending upon the memory address or wherever it happened to have been stored, it's not an ordered list. There's no ordering to it. It's not even a list. It's just a set of stuff we're putting together in terms of a set. So the interface sorted map extends map and maintains its keys in sorted order. So if you want sorted, instead of saying a hash map, you say, well, give me a sorted map or tree map. So the tree map implements the sorted map. So it takes and creates a tree structure, data structure out of it. And if you have no idea, this is why I asked ahead of time. I gave you the option. If you don't know about data structures, you have no idea what I'm talking about right now. But I asked and nobody wanted it, so I gave like 2 hours to my weekend class because someone said, yeah, tell me about it. But no. So now you're not going to ask because you don't want 2 hours. It's not going to take 2 hours. All right, I'll give you some when I go through the examples because I want you to understand the examples. Synchronize wrappers and the collections class. So we have this concept of the wrapper. So the collection class contains static utility methods, as we've seen, which can be roughly classified into 2 groups, those that are wrapped collections and those that don't wrap the collections. Wrapping the collection puts it all together in terms of a bundle, set. No, don't use the word set. Wrapper, wrap. So all the collections implemented, provided, what we've seen so far are unsynchronized. Unsynchronized. Synchronized, unsynchronized. So what does that mean? Well, when I hear synchronized, I always think of IPC, inter-process communication, threads. I always think of, while things are happening, do we sync it so that we have concurrency and we're able to run multiple lists at the same time and not have anybody fight with each other and I come with a deadlock situation or have something modify something first without something else modifying it. So we actually have built-in classes in Java to synchronize. We actually just put the keyword there, synchronize, next to the method, and it does your inter-process communication for you. It's kind of like does everything that C++, or actually people use C for this, I think, and they use the thread classes. And they have mutex locks and all semaphores, all these other techniques that they use. Java, one word, synchronize. So we have unsynchronized by default. We don't actually have to worry about that. If you do the 5th assignment, we have threads because we're running a ping pong game with multiple objects working simultaneously. You don't want the objects to hit each other. You want the objects to go on different round ping pong. Pong. So yeah, but we're not actually going to address that. So you can use synchronization wrappers for those collections that might be accessed by multiple threads to prevent potential threading problems. Threading from deadlock, starvation, and you don't want threading issues. And I'm going to assume, unless someone asks me, you know what inter-process communication is? Threads, thread synchronization? No one's going to answer. We have a very talkative group today. You guys are all wet from the rain. Your brains are all moist. When you dry out, you'll see clear. You go, what was she talking about today? I have no idea. All right, so the method collection class, if you want to get synchronized wrappers to it, look at that. Synchronized collection, synchronized set, synchronized sorted set. You just add the word synchronized in front of it. It's a new method out there, a new class. List, synchronized map. They use the word synchronized for everything. In fact, on the class, you can just put the word synchronized at the end of it, and now it's synchronized. Adds a wrapper for synchronization. But here we just have a different set. So we have a classes of different sets. All they've done is the same name of the class, you've just added the word synchronized in front of it. Because you want the collection that's going to play well. Because you're using multiple. And now I'm thinking about what are threads. There's a thread. Let me rephrase that. You have multi-threaded applications going on, whether you know it or not, or use it explicitly. So in this particular environment, you could have multiple collections running that might actually, or multiple sets running that might actually collide with each other, even though you may not necessarily be thinking that you're using threads. The concept is actually implemented in the JVM in terms of the way that the processes are managed. It's doing your synchronization for you. It's handling the whole thing in the JVM API. So when you say synchronize, you're just telling it, oh, look, watch out for collisions. Watch out for threads not agreeing with each other. All right, so in terms of the collection, the above method returns wrappers for those that are fully synchronized. And here we have map, unsync map, sync map. And it just depends upon On the sync map, we have a synchronized wrapper that's going around, so we can essentially not run into a problem. So. Unmodified wrappers and the collections themselves. These are the unmodifiable. So the collection class contains a set of methods and returns an unmodifiable wrappers for collections. So attempts to modify and return the set, whether direct or indirect, by the iterator results in an exception. And we're going to talk about exceptions in the next lecture, but you probably already know about the concept. To try to open up a file, you get and it's not there, you get an I/O exception. Here you get unsupported. You can't modify it. Which is actually kind of a level of protection added with built-in exception handling to tell you that if you don't use a list iterator and you're changing the list instead of just the regular iterator, then you're not going to be able to, no list changes are going to throw an exception. So you can't change the list. Because I guess what ended up happening is that Java developers kind of went, all these problems with these side effects in C++, let's just add them in as language features so we can synchronize. Add them in so that we can't change something unless we want to, unless the programmer actually intends to change it. So the contents of an unmodifiable wrapper, and everything's unmodifiable by default. Excuse me, it's unmodifiable. So the contents of an unmodifiable wrapper can change, but only through the original collection, not through the wrapper itself. So I'm actually not going to demo that concept, and then you're not going to have to worry about it, actually. In fact, not even in the assignment do you have to worry about that. It might actually be overload at this point, or overkill, but not bad to use if you're thinking about the concept of does it need to be synchronized or not synchronized, or I need to modify or make it unmodifiable. In fact, the syntax is the same, you just add unmodifiable collection. Instead of synchronize, you add unmodifiable set, which basically makes it so you can't do it through this wrapper. So it's unmodifiable. Let's see, here's an example. Original example is dangerous that the array's content can be changed. Kind of the classic problem that we have with arrays. Here we have an unmodifiable array list we're being used here. On collection, it says, you know, whatever we do with this, depending upon how we send it to a function, whatever we do with this, it's not going to be. We don't have any side effect that's going to happen to us. So the unmodified wrapper offers a read-only access to others, while read-write access is still available for the code itself. It remains in the reference to the wrapped. So the underlying modifiable underlying collection is modifiable. When you use it as an unmodifiable list, whatever you do to it, you don't have to worry about it. So, yes? Synchronize, yeah. If you had like a list item that was being used. If you think about the concept of arrays and how they accidentally, maybe when I said side effect, that wasn't clear. When you send an array as a parameter to a function in C++, or actually in Java as well, and you take the array inside of the function and you modify the contents of it, it gets modified permanently for the entire contents of that array for the rest of the running program. So in the old days, you know, when you pass something by value to a function, it was by value, which meant the value, whatever happened to the function stayed in the function. When the execution returned back to the regular part of the program, it was back to its old original value for whatever it is that you passed. When you pass arrays to functions, they end up by reference instead of by value. All of these structures are by reference by default, which means they're modifiable. If you want to send it, you want to use it in a fashion that you think might actually modify it, and you want to prevent the modification, this treats it like value. Actually, what it does is the structure, unmodifiable, takes a copy of it, uses the copy, which causes another problem, because if the contents of that array list change outside of its unmodifiable, when this unmodifiable returns, you've got inconsistencies going on between the unmodifiable list and the one that may have gotten changed while this was going on. That's why I say I'm not going to give you a programming assignment with this, because this would be worse than assignment number 2. This would be a nightmare. This is not a bad exercise for inter-process communication, or no, not inter-process. I keep bringing that word up, for side effects. Side effect. When I say side effect, I mean when something happens, you did not intend that to happen. Okay? Because when you passed it by reference, by value, it got passed by reference. So, which happens all the time in C++. Doesn't happen in Java, if you use unmodifiable. Or if you use synchronize instead of unsynchronized methods. So, abstract implementations. Okay. So the collection framework provides a set of abstract implementations for you to design your own implementations around. So we have relevant collection interfaces to satisfy your particular needs. Everything you could ever possibly imagine. Actually, there really isn't that much. I mean, you got a collection, a set, a list. So you can treat this like an abstract class that you're building upon. What is it going to do? It's going to give you the rules. It's going to say you have to have an add, you have to have a remove, you have to have... These are the implementations that are designed to help you as a developer come up with a fully functioning, abstract set or set or list of your own implementation. There's also a set and a list class, as we'll see, and it's already built for you. So the concept actually kind of works with the concept of an interface and an abstract. So both interfaces for these methods, for these classes exist, and so do the abstract versions of those classes so that you can build your own on it. So, legacy collection types. If you're familiar with older style programming techniques, what are we talking about? So the legacy collections contains some of the legacy collections than those we just looked at. In fact, those weren't legacy ones that we just looked at. The sorted array, the array list, those are pretty common stuff that people use all the time. They're still widely used in existing code. The list here, you can shift over to the new types, or here's an example, enumerations. Legacy, actually. When I say legacy, it means it's not very popular. Nobody likes to create vectors either. Why? Stacks, dictionaries, hash tables. If you're going to do a stack, you might as well just do a queue. If you're going to do a queue, you're just going to do an ordered list. So these are just, properties, to do a hash table, let's say, for a subclass. To do a hash table. We really don't do a property from that. So here's our vector. It's our array list, or iterator, or enumerations. So. Enumerations actually is a C++ thing. They're not even supported in Java. So. But there is support for it in the collections API, though. So. All right, now, if that all sounded like Greek, here's the real explanation of what's going on. With some examples you're going to like, because they're going to hopefully put all the pieces together. And I'm going to make this bigger so you can actually see it. Ooh, that's really big. All right, there's a video of this. And I do a much better job in the video, going through step by step, a lot slower probably too. It's in the assignment 3 section. But let me just show you what I'm talking about here. And actually I want to kind of show you a few different things as well in terms of Eclipse. Let's start out with a list example. Of course, my console was way up there. Okay, this one is called listexample.java. And you can see the way I'm getting the functionality. Something you guys, is this big enough? Should I make it bigger? Yeah, it's big enough. Actually, I can go a little bigger. There we go. It's practically sitting in your lap now. Okay. Because it makes no sense if you can't see what I'm talking about. All of the examples are including imports at the top here. That's all you have to do. I'm going to show you one that's got them all listed out. I wouldn't do it. I just do it this way. This is easier. All right. So I got this little thing here. Let's forget about the warning for right now. Let's go down into main. We'll take a look here. I've got a warning because I'm not doing any type checking, and I'm not listing any types actually. And I'm using raw type, object type, which means if I do any manipulation on this, it's not going to work. And I'll demonstrate that in a few minutes so you can kind of get a feel for what I'm talking about. Which is not what I would call, if you're a C++ programmer, you're going, what? You have a type list structure. What? How does that work? You can actually get away with it with these objects, with these collections, because what does it matter? If it's a list of numbers and characters. Yeah, theoretically, if you create a list of strings, all items should be strings. List of integers. All items should be integers. But here I've done actually something a little unconventional. If I take this thing out, it's going to tell me, in fact, this is just an Eclipse issue. If you write this out in Notepad, you're not going to get no warnings, no error messages, nothing. You won't even notice it. Let's take a look at the functionality, and I'm going to go through a bunch of these structures that I looked at that I've shown you in the slide set to make it a little bit easier for you to understand. So list equals new array list. You're like, oh, I didn't create an array list. You don't have to. It's in here. It's way up here. This is the beauty of Java programming, because you don't have to, in C++, you'd have to create that array list. It doesn't exist. So we have this new object here, and we're going to add 0, add 1, add 2. But I'm mixing and matching types in here because it's just objects. If I specifically said string integer, then I'd get an error message if I mixed and matched. Theoretically, this array structure should all hold the same. If you're using a list versus a collect, you should always store the same length, just like an array. You can't mix and match values in an array. Because what if we do an add, a remove? You could, and you have the flexibility to implement it, mix and match data types, is what I'm showing you. All right, so what we're going to do here, we're going to print out my list. Look at that. I just have to refer to the main object here, list. And all the little add items, 1, 2, 3, 4, 5, are already part of it. So it's kind of like how you print out the name of an array in C++, or actually you get the whole starting address, you get the whole contents of the array. So it's kind of similar. But look at this. I can actually add items without going list index value 0, list 3, list 4. I don't have to do that at all. I'm just running a method on it. But I still have the indexes built in. And I get that by going get 2, get 0. So list.get 0, list.get 2. I'm printing out to the screen 2 : the name of 0 so you can see that it actually works. And then we have below it, I used a data type. So to kind of show you, and if I put a number in here without a string, I'm going to get an error message now. So now I said linked list string q is equal to new linked list. I specifically, explicitly hold it string. There's many different ways that you can do it, like any other object you've created. You can take now string linked list q, and you can do it that way. This is just combining the 2 and 1. Yeah. You can create an object of linked list, of linked list string list. Q is going to be of a string type linked list. You can use conventional, or you can use this approach to explicitly declare it as string. Here, it's not casting. It's just I put this in here to kind of show you. It's actually commonly done this way, because why go out there and create another variable and then use that variable to hold the object? You can just do it all in one line, essentially. And you may not have seen that yet. But any other traditional way of declaring objects, there's absolutely nothing different. You're saying, give me a new linked list. But nowhere in the line did I ever say that Q linked list was going to be string type. So, all right. But you can do it any way you want, actually. So Q.add first, so we're adding first to the list. First, 6, 7, 8. I don't know. I guess I could have put first, second, third, fourth. Printing it out my Q with the name of the name of the structure that we created. Q.remove last. And then after the 2 last ones were removed, we're printing it out again here, and then that's the end, actually. So let's, yes? Oh. Yeah, I'm gonna give you the output so you can see what's going on. I had to make it a little smaller so I can run it. Actually, I can probably just run it from my, there we go, I can run it from, there we go. There we go. So what do we got here? My list, which was here. My list 0, 1, 2, 3. So you can kind of see how I played around with mixed match types because I didn't specify a type. And here I've got 2 and 0. That actually number 2 printed out here because I printed out index value. And then make this. Hello. There we go. There we go. So up here I've got 2, give me item number 2, which was right here. And then I've got 0, give me item number 0, which was 0. And then we have my queue, so this is the contents of queue that is not, that's put into adding to the first, adding to the first, adding to the first. So 6 was the first item that was added, 7 was the second, 8 was the third, 9 was the 10. So it gets added, it's just like a linked list when you add to the front of the list. Yeah, so it's backwards. So this looks backwards because we added to the front instead of adding to the back. It's kind of like the queue at a bank or something, a bank line. The first person is the first person that you normally take out. Well, we added, so that we added someone in front of the first person. It's actually not like a queue. We added to the front. So the first person now became the second person. And then we have a new first person. And then we have a new first person. And we got to say, so we're pulling hopefully from the back of this queue, to be fair. Yeah. So the first in is the first out. Yeah, it is a queue. And that has to jog your memory somehow. You know, first in, first out, last in, last out, last in, first out. All the different various combinations you might have on that. And after the last 2 were removed, where are the last 2? Here's the last 2. So we took out, we removed last. So now we have off of the end. So it's a true queue. Because we took out the first 2 that were put in, which were the last 2 in the list that we actually pulled out. We do. We have add. We have add last, add first, and you can extend the behavior to add your own type of add. Add in the middle, add every 2, add every 3. Any way you want to add it, you can extend the functionality by getting items, get 1, get 2, put in between. If you're going to build that much functionality into it, I would start with the interface. Excuse me, I would start with the abstract class and not build from this. But as we've seen in Java, in object orientation, any class is a base class for a superclass. So we can take this class and extend it actually, and make our specialized queue out of it. But I wouldn't reinvent the wheel. If you're going to do that, use abstract classes and start your own line, because you're really not creating a queue anymore if you change the functionality too much. So. All right, questions about the list example. That's pretty basic. It's the easiest one I could come up with, actually. So let's see, what do I got here? Set. Let's take a look at a set, how that differs. Get rid of this. So in our set, hopefully it should be looking boring. We got the java.util, same thing. All right, what do we got here? Same thing as before. This is the same warning as before, although I'm not really breaking it. In fact, I could just specifically define it, but I just left it alone. What do we have? We have set equals new hash set. So we're creating a hash set that comes with Java util. Set, add. Now we're not saying add first, and the set's not keeping track. Actually, we don't have an order to it that we're looking at. So in terms of an unordered hash set, we're printing out our set. Same as before, we're just saying set, print out the set. Which is easy, actually, because now we don't have to go, in the old days when you're using an array, print out the first item, print out the second item, print out I just print everything out. Just say set as the object, it returns all the objects. Here's the interesting part. We're taking the collection that's the hash set that doesn't have order to it, and now we're going to give it order. We're going to send it to a tree set. We're going to turn it into a tree set. And if you did programming assignment number 2, which is why for the weekend class I went over that before I went over this, because they're going, what do you mean? You guys had to take that person, you were storing an array of people. For those who did the assignment, you know what I'm talking about. And then hopefully what you did is you figured out, is that person an instance of employee? Is that person an instance of a student? You found out who that was an instance of. And the employee, or the instructor, was all of the above. It was an instructor, an employee, and a person. They're all people. They're all persons, instances of that object, so they can all be stored in a like array of person objects. But what you had to do is take the object, find out inside of the object, and then treat it like that to run their individual methods, which was the trick. I'm glad you guys figured that on your own, because now you guys understand this. You're taking the set and you're putting it inside of a tree set. And now you're saying, sorted set, you can still use both. They're both still there if you wanted to. You can still add items to the set inside of the tree set, actually. But now we have a tree set that took on the default constructor, took the set, created a tree set out of it, and now we're just going to print out the tree set, which is going to be a sorted set. And I had to do a double take on this one because then I had to go, actually, here, let me print it out. I don't know if there's any sort order to this, actually. Let me run it so we can see what the output looks like. It is sorted. No, it isn't. 1, 3. It's a tree, though. But what we got is our set, which is 2, 1, 3, 5, 4 that I added in here. But we don't have any order to it. So what's interesting to note is that the hash set that was created was of an arbitrary order. It wasn't quite the way that we added the items to it. And then when we created the tree set, maybe it's up this way, 1, 2, I don't know the order of that, seriously. But it's in a structure. It's in a tree structure instead. Interesting to note, the order got changed. It's sorted now in terms of the tree structure. We can run tree methods on there to traverse the tree and all the different branches. It's not printed out like a tree. It's printed flat, so. I don't know. What do you think it is? Alphabetical order. 5, 4, 1, F, O, T, T. Yeah, no, then 2 would come before 3, wouldn't it? No, 2, H, T, W. Yeah, alphabetical order. Yeah. But the tree set is not necessarily alphabetical order, though. So we're not doing anything with it. That's the problem. If we use the tree structure and we implemented a syntax abstract, maybe for language processing or something, people take trees so they can put things in relationship to other things and branch them out normally. Again, if you don't know about data structure, you have no idea what I'm talking about when I say abstract syntax tree or tree. You don't know what a hash table is either, probably. But the tree is for traversing paths. And an example, really slow algorithm, not used, but you could implement a GPS program using a tree. Because what you do is you say, I want to go from point A to point B. Map out all the different routes. So you have one route that goes this way, one route that goes this way, one route that goes that way. Find out which one's the shortest route. Will they traverse the tree? They'll say mileage here, mileage here, mileage here, mileage here. And then you get a ratio. Say, well, 12 miles, 10 miles, 5 miles. Ooh, I want to go 5 miles. You know, how long do you want to travel to get from point A to point B? Classic idea, actually, in terms of the tree. So you would pick out coordinates, you'd load them into a tree structure, and then you'd read the tree, essentially, which is why you create that tree. To find out, you know, distances, to find out paths and stuff like that. You know, which one doesn't use freeways, which one does, and stuff like that. So, all right.
You said we set the order in an
Ascending? Oh, good. So we got the expected behavior then. Oh, very good. So it does list it by default in ascending order.
Yes.
Oh, good. Very good. So now let's take a look at combining these objects together. I've got a linked list example here that you're going to love if you're a C++ programmer. And instead of saying java.util.asterisk, I made it harder. I didn't make it harder. I just basically said java.util.collections, comparator, and linked list. You could have just put an asterisk there. But this is showing you explicitly, these are the classes I'm talking about in the lecture that we're implementing here. So we're creating a class that's called linked list example. And again, here's one with integers in it. And explicitly saying, let's put integers in there. I don't have any warning messages on this one. Actually, I think what ended up happening is I edited this during the last weekend in class, so I took it out to show somebody something with it. They never changed it back, so it doesn't matter. What I've got is the name. This is the weird part of the example that some students had some confusion with. It's LL. That's the name of my linked list. I know, it looks like 1-1. What's that 11.11? It's LL for linked list. I guess I could have used bigger words. I don't know. But anyway, you should be able to, at this point in the course, you should be able to do that and understand what this means. It's the name of the object that we're dealing with. So we have ll.add, and I'm using integers, -8, 20, -20, 8. I guess I could have put some more interesting ones in there. Now we have a comparator. So the comparator is also going to be of an integer type, and we're calling the comparator R. And the comparator is going to take and run collections.reverse order. Your assignment has you take and run collections.sort on your hash mash whatever multi-hash map. You're creating a multi-hash map. Yeah, okay. So you're running collections.set. This is where this is coming from, so it kind of gives you an example. This is why I have to have this in here and kind of show you how to create it. And what you're doing, this is the method you're actually running in the assignment. So we have, and we're setting the sort for the collections reverse order method. We've got the linked list with R. R is our, we could have just nested this. And you nest it and people look at that and go, oh my God, what in the world is going on? Because you're making an object up from an object inside of an object. So it's more classically seen to create an object for a comparator, create an object for an iterator, which we'll see in a few minutes. Run the iterator on the object, send the linked list object to the comparator object so that the collections can do a reverse sort or can do a sort on it. So what we're doing here is we got R, which is the collections, and the collection that we're going to create is going to be in reverse order, and we're going to sort it with the particular linked list that we created, and we're just going to print it out. So the list sorted in reverse order is going to be printed out, and don't worry about the syntax. There's just another way of doing it again, and in fact, it's just an iteration. You could put a regular for loop in there if you wanted to. But this is, actually you can't. You have to do it this way. For I to I in linked list, I, because we're printing out the order I for a for. Deedle and deedle comes in handy if you don't understand the looping. Or go on the internet. All right, so we're printing out I, which is the order, with the particular item spaced out. Or I is the item, excuse me, for I of the linked list. We're printing out the items of the linked list. How much more can I botch that one? All right, now we have collections.sort the linked list, shuffle the linked list. I could botch it more. So the shuffle is going to not put it in. It's going to put it like randomly, throw some dice for the shuffle. It's applying a random actually to it, but it's shuffling it. The shuffled list, we're printing out the list here for all items in the list, and now we're just going to print it out, and then we're going to go the minimum of the selection and the maximum of the collection. This one isn't showing you. No. Okay, good. No, it's in my other example. I thought this was going to demo something else as well, but it's in the next one. So. All right. So if we run this one, we get the list sorted in reverse order. This one I had to do a double take on to remember math. -8 is bigger than -20. I looked at that and went, that's not right. Wait a minute. Oh, yeah, it is. You shuffle the order, and if you run the program a couple of times, the shuffling should be different. Yeah. Actually, when we want to test it, we got 8, -20, -8, 20. It depends on the algorithm, I think. If the algorithm doesn't keep track, it might shuffle it the same. It's shuffled it the same. So shuffling is not going to be that useful, especially if you're running a gambling program. I'd bet on the on the order that comes out. Well, 7. Okay, the next one's going to be another 7. All right. The minimum and the maximum value. So it allows us to take a collection, sort it, and then the collection that we started out with was a linked list that was unordered. provide a comparator to it so we can compare items in the linked list, and then run a shuffle and run a sort on it. So basically demonstrating how you put those three components together. Okay, list iterators. This is where we have, I believe I put both the modifier list, the list iterator, and then the iterator. Yes, I did. Okay, good. Okay, so same as before. I just put the dot asterisk on here. We have a list. We have Iterator Example, and in here we're going to create an array list. So array list AL, how unique, is equal to new array list. Add elements to the list. Array list 1, 2, 3, whatever, A, B, C, D, E, F, and we're going to use an iterator to display the contents. So we have this is the common problem actually, is you kind of see that you need to actually add an iterator to the array list. So here it is. We have an iterator ITR, common, al.iterate. We're running the method iterator. It's a method of iterator that we're running. And while ITR has next, then the object element is going to be equal to the next item. So has next checks to see has next, and then one says take the next one, take the next one, take the object itself. Then we're going to print it out to the screen. If we did that over here on the bottom, we get a problem unless we actually, because now we're altering the list. So this is going to give us the results we want. If we took this and did it again and put a plus next to each one of the items, it wouldn't do it. I mean, it wouldn't alter the list. It would just essentially print it out like that. If we actually want to alter the list, we actually have the same thing all over again, where we have a list iterator, so we can modify the items while we're iterating through the items. So this is demonstrating that as well. So we have same concept as before, creating that object, and then now we're saying has next, and now we're putting a plus symbol next to each one of the items in the list. And we're going to print out the modified contents of AL by going through the iterator here and printing it out after the fact. So we've iterated through it. Now we're printing out the changed list that has been modified. And then what do we have on the bottom here? Modified list backwards. Oh, we're just going to print it out backwards. So we got it. Instead of next, we're doing has previous. It's the same thing as the has next, but we're going in the opposite order, printing it out backwards. So we have has previous, has previous. So. And if I run the sucker, let's see. My screen is so big. Oops, and my console went away. There it is. All right, so the original contents was the C, A, E, B, D, F. The modified contents, and because we're printing it out, we can actually see that it was modified because now we're printing the list itself out in reverse order. Here we go. List iterator. So we can see it's been changed. It's been modified permanently. The reverse order looks like alphabetical. No, it's the order itself, the order that we put the item in. So, yeah, because it's an array list. So. That's an example, actually, of all of those different collection components put together. There are more. I mean, I could spend maybe 5 different lectures going through every one of them, but I'm not going to. Those are the common ones. Most people find a need to put together a linked list, an array list, something. You know, in fact, any array lists are very common to use instead of arrays, because why would you want to use an array anyway? It's an outdated data structure that is fixed. So you're going to do some application development. This is extremely easy to put together, and then you don't have to do any more looping anymore either. You just put it in. You just create an iterator and go through it, or you create a list iterator and go through it, or you use Synchronize if you think something has changed and you want to keep consistency with the thread activity, or you make it not modifiable and remove any types of handicap, any type of side effect that might occur as well. So it gives you a lot more flexibility, but you're not going to use it unless you know about it. Essentially, what ends up happening is a lot of Java programmers or C++ programmers, and I've actually seen linked lists implemented without using. I've seen this in real life. People creating linked lists in Java with not even touching the Java util. It's like, why did you create a link? Why did you create your own linked list structure of objects when one exists? Which makes no sense. Or using, creating their own array list. That's an assignment you would do in C++, essentially. And maybe I'm outdating myself, but I don't think they've even implemented that as part of the core libraries. The current version of Visual Studio, or some of the Microsoft C++ versions. I don't know. I wouldn't be able to answer it because I've stopped using C++ years ago. All right, questions on the collections concept? That's everything I ever wanted to know about, well, not maybe. Actually, at this point, what you need is some practice, so that's what assignment number 3 is about. Assignment number 4 is on GUI, swing components. But before we get there, I think next week is on exceptions, IO exceptions and things of that nature. So we'll eventually get there. This particular class, we've got a few more meetings. The weekend is running on an accelerated schedule, so I have to fit everything in when I can fit it in before that class ends. So. All right, so you all got the announcement last week about the midterm exam, and it's due on the 17th of April. Do not send the CSLOs to your TAs for approval. That was something that happened last semester. New people don't know that, so they don't have to worry about it. But existing people are asking already questions about, where do I send this to? Or thinking that they have to send it to the TA. No more emails, no more previewing. As you've probably, hopefully, have realized, it's a different assignment that we've had last term. So you upload it directly to the ITU EMS. If you have questions about the ITU EMS problems, is it tech support? Tech support at itu.edu. They are going to be so upset that I gave them this out. Tech support, send everything you could possibly send to tech support at itu.edu. Run them all over the place because they need to fix the problems. Don't bother. If it's a problem with the ITU EMS and you're having problems, you can send the TA a message, but they can't really fix anything. It's the technical support people that need to fix the problems. So I highly encourage you to send all of your problems to them. Because after they hear the problems, maybe they'll fix them, huh?
The tech support team needs the details. Who has the problem? What is the exact problem?
Oh, so they need your name, student ID, they need your email address.
And the course name.
The course name that you're having. Oh, yeah, that's good. Actually, when you send the message to technical support at itu.edu, technical support or tech support? Tech support. TECH support. Oh, you sent it. Oh, okay. So the TA must send a message already. Make sure to include your name, the course name, so because I need to know what version of the course, what section you're having a problem with, and what student ID, email address, favorite color. No. Okay. That's enough? That's all they need? All right. Bank account numbers? Credit card numbers? They don't take bribes. All right, I think we're done for today. Yes? Oh, we're not done. Very good. Thank you. See, my TAs are really doing their jobs today. Next week, are you sure about this?
Yeah, sure.
Okay, they say we're sure. Next week, we're going to be in our new building.
Yeah.
Don't come here next week. Oh. Come here, but come here over there. Come at San Jose location. You guys have the address? You guys know where you're going? Same class time. It's like Batman. Same bat time, same bat hour, different location. Same time, same day, same teacher, different location. Same school, too. All right. Anything else I'm forgetting? No? All right, we're done for today.